3127 to the power 173. Remember what we did here the last time? We divided 173 by, or rather the exponent by 4. So let's divide 173 divided by 4. Whatever the answer is, the remainder is 1. There. 4 4s are 16, 1 3, 4 4 3s are 12, so 1 will be the remainder. Clean. So we remember the rule. If remainder is equal to 1, 2 or 3, it is the last digit raised to the remainder. So last digit here is 7. This 7 raised to the remainder, that's 1, 7. So the units digit of 3127 to the power 173 is nothing but 7 raised to power 1, 7. So this number will look something like this, big number, the last digit being 7. And let's 10, because total numbers can be 0, 1, 2, 3, 4 till 9. So there are 10 digits, 10 numbers are there. And R is 4 because 4 distinct numbers are to be picked up, 4 digits are to be taken, 4. So the total arrangement may be factorial 10 by 10 minus 4 factorial, which makes it factorial by 6 factorial. But there's a twist here. Remember, if there are 4 numbers, an n distinct number, we have taken 0 into consideration, so we will have a certain number of numbers with 0 in the beginning, in the thousands place. Hence, those numbers have to be excluded, because this number becomes a 3-digit number now. So 0536 is not a 4-digit number, it's 536. So similarly, there may be combinations having 0 in the thousands place. So it may be 0 followed by x, y, and z. So I'll have to exclude all those numbers which are having this combination. So if this is the thing, and 0 is fixed, if this is fixed, for this we have got 9 digits. So 9 digits remaining to be rearranged, taking 3 at a time, obviously, because there are 3. So here n becomes 9 and r becomes 3. So the number of arrangement possible is 9 factorial by 9 minus 3 factorial. So that makes it 9 factorial by 6 factorial. So the total number of 4-digit numbers is 10 factorial by 6 factorial minus 9 factorial by 6 factorial. Great. Okay, let's go to the next one and see. Find the sum of all the numbers that can be found by the digits 2, 3, 4, and 5 taken all at a time. So this is a bit of a different question. So sum of all the numbers that can be found by these 4 numbers. So we have got fixed number of digits. So the total number of numbers is one second. Is factorial 4 because there are 4 numbers. So which makes it 24. Now to find the sum of these 24 numbers, what is asked is the sum of all the numbers. So sum of all the 24 numbers, we we have to find the sum of the digits at the units place, at the hundreds place, units plus the hundreds plus the thousands place. Then only the, the correct combination will happen. If that is the situation, let's see. 1, 2, 3, and 4. Step 1 can be, we can fix 2 here in the unit space. The remaining is factorial 3. So which is 6 ways. So the total number of digits in the units place, and if we keep swiping, if we take 3, then instead of 2, we can 3, we can fix 3, we can fix 4, we can fix 5. So the total numbers can be, the sum total can be 2 multiplied by 3 factorial. Here the sum is 2 multiplied by 3 factorial. While we keep swiping these, it can be this plus 3 multiplied by 3 factorial plus 4 multiplied by 3 factorial plus 5 multiplied by 3 factorial. Do a simple calculation, this will become 2 plus 3 plus 4 plus 5 multiplied by 3 factorial, which is 84. But remember, this is only for the unit space. This is only for the unit space. Now, what to do for the rest of the places? For the tens place, it is 84 into 10. For the hundreds place, 84 into 100. For the thousands place, it will be 84 into 1000. So let's add up 84,000 plus 8400 plus 840 plus 84. Whatever is the number is the sum of all the numbers formed by these 5 numbers. Okay, let's go to the next one. There are 6 periods in each working day of the school. In how many ways can one arrange 5 subjects such that each subject is allowed at least 1 period? Fairly simple question. Let's say there are 6 periods and there are 5 subjects. Having said that, so the 5 subjects are to be arranged in 6 periods, then 450. And the rest 50% scored between 450 to 700. This much. If I look at this data, this is what I can derive. So the 95th percentile score can correspond to any number more than 700. Say it can be 750, it can be 780, it can be 790, it can be 800. God knows what. Quantity B is 800. So we do not know. This can be any number. So D. Data is insufficient. We cannot predict the percentiles. Okay, this is somewhat interesting, comes pretty handy. Let's understand this part. In GRE and GMAT, whenever there is a normal distribution, if this is the mean and the standard deviation is +1 -1 +2 -2, the distribution in terms of percentage will be 34% on the either side for an SD of +1. For +2, it's 14%. For +2 +1, more than 2 standard deviation is 2%. So remember this 34, 14, and 2. This is on either side. So if I go on the other side also, SD -1 -2, 34, 14, and 2. So a normal graph will always look like this. Sorry, I'm pretty bad at this. The mean 1 SD and this is 2 SD. This is 1 SD and this is 2 SD. Here. Now in this case, this question becomes very easy. A species of insect has an average of 5.2. So this mean is 5.2. The standard deviation is 0.6. So SD is 0.6. The mass of the insects follows the normal distribution. So it's 0.6 on the side, either side. Then this becomes 5.8 and this becomes -1. So this becomes 4.6. Then this becomes 4 and this will become 6.4. This is the typical distribution. So our old formula 34%, 34%, 14%. Remember, this is normal distribution. It should be given, otherwise we cannot plot this kind of a graph. The percentage of insects that have a mass between this 5.2 and 5.8, between these two, 5.2 and 5.8. This is equal to 34%. The percentage of insects that have a mass between 4.9 and 5.5. 4.9 will be somewhere here. And 5.5 will be somewhere here. Now, not to get into calculation, this is the upper end. So this is bound to be more than 34%. Then we remember this one, dA square is equal to dB into dC. H square is equal to m into n, something like this. Say this is M, this is N. So recapitulating the old thing, quadrilaterals and polygons. What's a regular polygon? All the sides and the interior angles are same. We are going to deal with regular polygons only. We do not want to deal with absurd figures. Regular polygons are convex. That means they are always pointing outside. Let's draw a regular polygon. Let's draw something like this. A shape having equal sides, but 1, 2, 3, 4, 5, 6. So there are 6 sides. This is called as a hexagon. So this is a polygon. Regular sides, all sides and interior angles are same. So this angles and these sides are all same. So then only we can call it a regular polygon. They are convex, that means they are pointed outside. There can never be a absurd figure which has got something like this. We are not going to deal with such figures, so this is not there in our case. All interior angles are less than 180 degree. So remember, all these angles, they are less than 180 degrees. All vertices points outward away from the interior. So obviously they are all pointing outside. Now, this is for our understanding. What comes handy are these two. The sum of the interior angles of a polygon is 180 multiplied by 2 minus n minus 2. Sum of the interior angles of a polygon are 180 into n minus 2. So, where n stands for the number of sides. So, it has got 6 sides. This is called as hexagon. So, 180 into 6 minus 2. This is that 180 multiplied by 4. This is the sum of the interior angles. Other way around, just think about it. Whenever I am having a hexagon like this, if I take one of the vertices and start making triangles. So there are 1, 2, 3, and 4 triangles. So 4 triangles are there. We know that the sum of interior angles of a triangle is 180 degree. So there are 4 triangles. So 4 into 180. Any polygon you take a square from one vertices. There are 2 triangles. So the sum of interior angles is 180 into 2. Or if I put it this way, 180 into n minus 2, which is 180 into 4 minus 2, which is 180 into 2. The formula comes pretty handy. So if I know this formula, then the other thing, each of the interior angles is, so what is the each of the interior angle? 180 into n minus 2, which is the summation divided by the number of sides. Okay? So we'll remember these two formulas only, or rather this one formula is good enough to do our calculations. Basic idea of polygons can be drawn. Basic 4-5 types of polygons we are going to deal with are squares, rectangles, parallelograms, trapezoid, and rhombus. That's it. We will not deal with any other kind, hexagon, pentagon, octagon, etc. So to get a basic understanding of what is parallelogram or a quadrilateral, so this is why we say the parallelogram in quadrilaterals. This is one type of thing which we are going to use time and again. So a parallelogram is actually quadrilateral, but 2 sides are parallel to each other. So these 2 sides are parallel to each other. Properties of a parallelogram: the opposite sides of the parallelogram are equal in length. So if I so this side and this side are equal, this side and this side are equal. It can be like this also. So this side and this side are equal, and this side and this side are equal. The opposite angles of the parallelograms are equal in measure. So this is equal to this, and this is equal to this. So if this is A, B, C, and D, A is equal to C and B is equal to D. The diagonals of a parallelogram bisect each other. So diagonals will bisect. That means they will break up into two parts. Consecutive angles are supplementary. That means this plus this, or this plus this, are 180. Clear? Or this plus this, or this plus this is 180. Area of a triangle of a parallelogram is based into height, the base of the parallelogram, and the height of the parallelogram. So this is the base, and say this is the height of the parallelogram. So area is equal to base into height. Fair? So as we know, a parallelogram is a quadrilateral with opposite sides parallel and congruent. We can further extend it to something called as a square, a rhombus, or a rectangle. So what's a rectangle? Rectangle is a parallelogram with all sides fixed at 90 degrees. So that's same as square, but the sides differ. So that's the only thing different between rectangle and a square. But what's a rhombus? It's a parallelogram where all the sides are equal in length. This is important. Factorial 6 divided by 3. That makes it 6 into 5 into 4. That's 120. With this in mind, the total number of ways is 24 into 60 into 120. Why this multiplication? Because this is the thing. In how many ways can they wear them? Means they are taking everything into consideration. Let's see the next question. That makes it easier. Again, 3 men, 4 coats, 5 waistcoats, and 6 caps. In how many ways can they wear them if wear any one type of them? There is a twist here. That means the previous thing, 3 men, 4 coats, makes it factorial 4, which is equal to 24. Or 3 men, 5 waistcoats, makes it factorial 5, 5 factorial 2, makes it 60 arrangements. Or 3 men having 6 caps can make it 120 ways. But here any one of them have to be chosen. So this one or this one or this one. So when there's an or question, then what do? We add. That means the arrangement of 4 coats or 5 waistcoats or 6 caps. This means the 24 plus 60 plus 120. This works out to 204. Let's go to the next one. In how many 4-digit numbers are there? Uh, how many 4-digit numbers are there with distinct digits? Well, let's make a 4-digit number. So that's 4-digit number means 1, 2, 3. Clear? and every number has to be distinct. That's what they are saying. So total number of, so n in this case is 10 because total numbers can be 0, 1, 2, 3, 4 till 9. So there are 10 digits, 10 numbers are there. And R is 4 because 4 distinct numbers are to be picked up, 4 digits are to be taken, 4. So the total arrangement may be factorial 10 by 10 minus 4 factorial, which makes it factorial by 6 factorial. But there's a twist here. Remember, if there are 4 numbers, and n distinct number, we have taken 0 into consideration. So we will have a certain number of numbers with 0 in the beginning, in the thousands place. Hence, those numbers have to be excluded because this number becomes a 3-digit number now. So 0536 is not a 4-digit number, it's 536. So similarly, there may be combinations having 0 in the thousands place. So it may be 0 followed by x, y, and z. So I'll have to exclude all those numbers which are having this combination. So if this is the thing, and 0 is fixed, if this is fixed, for this we have got 9 digits. So 9 digits remaining to be rearranged, taking 3 at a time, obviously, because there are 3. So here n becomes 9 and r becomes 3. So the number of arrangement possible is 9 factorial by 9 minus 3 factorial. So that makes it 9 factorial by 6 factorial. So the total number of 4-digit numbers is 10 factorial by 6 factorial minus 9 factorial by 6 factorial. Great. Okay, let's go to the next one and see. Find the sum of all the numbers that can be formed by the digits 2, 3, 4, and 5. Let's take another one. A tea party is arranged for 16 persons along 2 sides of a long table with 8 chairs on each side. Fair. This is okay. A tea party, 8 chairs on each side is okay. But the twist comes here. 4 persons wish to sit on one side and 2 persons on the other side. So how many arrangements are possible? Let's draw a table quickly. 2, 3, 4, 5, 6, 7, 8. Here also there are 8 chairs. Here also there are 8 chairs. So total 16 people are there. 8 chairs are there. If that is the case, but we have got 4 persons on one side and 2 persons on other side. So if there are 4 persons on one side, then 4 persons on one side. That makes it 8p 4 ways. 2 persons on another side. We are arranging this set first. Then it is 8p2. With 4 plus 2, 8 people taken care of. Sorry, 4 plus 2, 6 people already taken care of. So there are 6 people already got seated. We have got 10 remaining out of the 16 people. So 16 minus 6, it makes it 10. So we'll have to set all these 10 people. Obviously, 10 places for 10 people, or rather 10 persons having 10 chairs or places to sit.